So let's conclude this chapter by answering some equilibrium problems. Okay. So for this problem, we have to calculate for the Ka of an acid HA given that 0.70 molar of HA has a pH of 4.0. So in order for us to answer this, we should have a reaction first. Okay. So if you're given this problem, you're going to write the dissociation reaction of your acid HA with water to form hydronium ion plus your conjugate base. Okay. So that's the idea. And we're going to use ice table. So how are we going to interpret the problem into the ice table? Okay. So this 0.70 molar of HA, that is the initial concentration of your acid. So this is 0.7. Okay. So what is the initial concentration of H3O and your conjugate base? So we don't have any information about that at first. Okay, so this is 0, this is 0. Since this water is liquid, we're not going to write any in the ice table column for water. Okay, so that's the idea. And according to the reaction quotient, if we do not have any products, the reaction will proceed towards the product. So that means this is negative x, this is positive x, and positive x. That brings our equation in equilibrium for HA 0.7 minus x. For H0, that's its x, and A minus, that's x. Okay. Then this is a typical ice table. How about this term? How about this one? The pH equal to 4. What does that information tell us? Okay, so if you could remember, pH is the negative log of the hydronium ion concentration, or we can simplify this as the negative log of H plus. Okay, so that means that a pH of 4, using that information, we can get how much is this? How much is the hydronium ion concentration in equilibrium? Take note, in equilibrium, not in the initial concentration. Okay, so in order for us to solve for the value of the hydronium ion in equilibrium, that is, we have to remove the H3O term from the log function using the anti-logarithm function. So you have to multiply both sides by negative sign. Okay, so using the anti-log function, we'll get the concentration of H3O being equal to 10 raised to negative pH. Okay, and this is the anti-log function. Okay, so that is equals to 10 raised to negative 4. Okay, so that means this x is equal to 10 raised to negative 4. That also means that this x is still 10 raised to negative 4. And that also means that this x is still 10 raised to negative 4. So that means we can now solve for the K. The K for the reaction is the concentration of H3O plus times the A minus over concentration of HA. So that is 10 raised to negative 4 times 10 raised to negative 4 over 0.7 minus 10 raised to negative 4. So Ka for this problem is negative 4. .7 minus 10 raised to negative 4. The value of Ka is 1.43 times 10 raised to negative 8. Okay, what you have to take note is that the pH represents the equilibrium hydronium ion concentration. Okay, equilibrium hydronium ion concentration. Okay, you have